Question 1. To find the largest sum contiguous array, in this question we will use the approach of Canton's algorithm, meaning first we will initialize two variables, max ending here that is, and max so far. And we will look for all positive contiguous segments of the array through max ending here and keep the track of maximum sum contiguous segments among all the positive segments through max so far. Each time we get the positive sum, we'll compare it with max so far and update the value. And at the end we will return max so far. So let's jump to the code. Here A is the array and n is the size of the array. Let's initialize our two variables, max and here. Now we will loop through these variables. If max ending here is less than 0, then we'll update the value of max ending here to 0. Since we are looking for the first positive segment, now let's jump to our example. When I is equal to 0, the first value in max ending here will be minus 2. and since max so far is not less than max ending here, so we will just move on. And second, the value of now I is 1. Here value of a of 1 is minus 3. This will be minus 3. So here I missed a step, that if max ending here is less than 0, we will reset its value to 0. So in both the cases, in case of minus 2 and minus 3, max ending here will become 0. Now when value of I is 2, so a of I is 4. This time max of ending here is 4, and it does not satisfy this criteria if it is less than 0. So it will move to the next if loop. If max so far is less than max ending here, it will update its value to 4. Again for I is equal to 3, this is minus 1. We will add minus 1. Now this value is 3. Since max ending here is not less than 0, it will not become 0 and it will move to the next if loop. If max so far is less than max ending here, which is also not true since 4 is greater than 3. So now it will move to the next value, that is I is equal to 3. Now I is equal to 3 minus 1. We have been through minus 1. I is equal to 4 minus 2. Let's add minus 2. The value is 1. Now 1 is also greater than 0. So it moved to the next part. If max so far is less than max ending here, which is not true, so it will move to the next value, that should be equal to fifth value, that is 1. Now the value is 2. Max ending here again is not less than 0, so it will move to the next if loop. Max so far is also not less than max ending here, so it will continue. Now value of I is 5. Value of I is sixth element, that is 5. Let's add 5 to it and we get the value 7. This time max so far is less than max ending here, so we'll update the value to 7. Now it will go to minus 3. Max ending here is not less than 0, so we'll move to the next if loop. But max so far is also not less than max ending here, so the final answer is we'll return max so far here. The value is 7, which is the largest sum contiguous subarray. Time complexity, we go off in space complexity, we go off 1. Test cases, first per 10 elements in the array. Second would be only one element in the array. Very long array.